What is going on, guys? Welcome back. In this video today we're going to learn how to generate truly random numbers, not pseudo-random numbers in Python. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so I think a lot of you guys might already know this, but when you use the core Python module random to generate random numbers, you're not actually generating truly random numbers, you're generating pseudo-random numbers. And of course we can get into the philosophical discussion of whether anything can be considered random or not, but there's a difference between taking some random noise out of nature, or at least seemingly random noise out of nature, and generating numbers based on that, or having a mathematical formula that you provide a seed to, and then you get deterministic output. And this is exactly what the core Python module random is doing. So when you say import random, and when you then generate a random number here with random.randint, for example, from 0 to 10, then you print the result. This might seem random, but it's actually pseudo-random, so it's actually a formula in the background, a mathematical formula that is predictable. When you provide a certain seed, it's always going to give you the same output. So I think you do that with random.seed. If I say 20, I'm gonna get 10 every single time, because that's not actually random, it's a mathematical formula. And to be precise, it's the Mersenne twister. I don't know exactly how it works mathematically, but this is the formula in the background that random uses. Now, how can we then generate truly random numbers, or at least random numbers that depend on some nature stuff, on some physics stuff that is not a mathematical formula that we construct to generate pseudo-random numbers, but at least if we set aside the philosophical aspect of whether anything can be considered random, at least more random than these pseudo-random numbers. We can do that with two, probably more than two, but in this video we're going to look at two different sources that we can get random numbers for. The first one being random.org. They actually use atmospheric noise to generate randomness, and they have many different endpoints that you can use for different tasks. We're going to just generate integers here, but how we do that is we import the module requests, which is not core Python, so if you don't have it, you just install it via the command line with pip or pip3 install requests. And then what we can do is we can send a request to the endpoint, which is https then www.random.org/ and now we choose the endpoint, in our case integer or integers, and then we have these URL parameters with a question mark here. We're going to say number equals 1. We want to have one number. We want to say minimum equals 0 and maximum equals 100, for example. And then we're going to say base equals 10 and format equals plain. So that is the URL. We're going to now say number equals requests.get URL, and this should provide us with a random number. So let's see if that's the case. No, why is that? Let me see if I missed some. Oh, I think I need to also say and rnd equals new. Not sure if that's the problem. No, okay, let me just double check again. Random org integers num equals 1. Probably we need to also, I don't actually know what this keyword is for, but I have this call equals 5 in here. There you go, now we get a response. Okay, probably I'm going to show you some text here explaining what this call does. Either column or color, I'm not sure. But essentially now we have our number. To actually get the number, we need to access the text. And you can see now when I run this, I get 30, 43, 78, 30 again, 34, and so on. And this is a random number. Of course, we would have to convert it to an integer to actually work with it. But that is a random number generator that is based on atmospheric noise, so we could call it quote-unquote truly random. Now, the other source that we could use, and this is a more limited source because we can only send one request per minute, is we could request a quantum random number generator from I guess it's a university, And for this, we would say response equals requests.get HTTPS ://QRNG for quantum random number generator .anu.edu.au. So this is basically an Australian university, I guess. And they have a quantum random number generator. So we access the API, we say JSON i.php is the endpoint, and then question mark length equals 1 and type equals uint16. That is the URL. Now we need to do this perfectly now, because if we don't manage to send a request properly, we're going to have to wait for another minute. But we can say now response.text to see the response, and then we can also say data equals response.json if it doesn't fail. If we don't get an error, this should work. And then we can say the random integer is whatever we get in the data field, and then the first element of that. So this would also give us a random integer. However, I think this only works once. So this is now a random number, but if I run this again, probably we're going to get an exception. There you go. And it's probably going to tell us here, yeah, limited to 1 request per minute. So I think the more viable option here is to use random.org. And you can also explore the other endpoints, but this is at least more random than using a pseudo-random number generator. So if you decide to do something to generate numbers and you want to have truly random numbers, not something based on an algorithm that you provide a seed to, then I would recommend you use random.org. And I think there's also a Python module called secrets that you might want to look into if you have to generate random keys for cryptography. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.